Fuedu. I'm a business strategy consultant and a data scientist. If you've been following my channel, you know that I've been talking about data science and how people can actually start their journey into data science, especially in Ghana. Today, I have with me a very brilliant Ghanaian who currently works outside the country with Capital One Bank. And we'll be having a discussion on data science, how he got the job, how he went into data science, and a whole lot of other things that will be insightful for our subscribers and our viewers. So I have with me today Dr. Emmanuel Nii Martey. He is a very young, dynamic, brilliant scholar. I've known him for at least some 12 years. And Dr. Emmanuel Martey is a principal data scientist at Capital One Financial Corporation in McLean, Virginia, USA. He joined Capital One's foundational testing team, which is part of the CAR-DS Plus Valuation Infrastructure and Testing Group. The team focuses on all things related to foundational testing, including the design and analysis of credit card financial experiments, horizontal valuations, models, and credit policy analysis, as well as training and consulting and in best testing practices. I would not continue with, he is a trained civil engineer with a bachelor's degree in civil engineering. I think it will be nicer when he tells us and how probably he got into data science. So welcome, Dr. Emmanuel Martey.
Thank you, Ebenezer. Thanks for having me. Yeah, like you said, my name is Emmanuel Martey. I'm a principal data scientist at Capital One. As you said, I started out initially as a trained civil engineer. I had my bachelor from the University of Nkrumah, University of Science and Technology, and I subsequently did my national service at the Nkrumah University of Science and Technology as a teacher assistant, teaching various highway and transportation courses, and I also doubled as a master's program assistant. Then I subsequently.
I would like to cut in here. So you mean you started in Ghana? I'm sure your old students would be so proud of you. At least you'd have started from that end where you could have mentioned your secondary school.
Oh, yeah. So I went to the Presbyterian Boys Secondary School. That's PSEC, the best secondary school in Ghana. 6 times national winners in Ghana. Yeah, I started from there. I did general science, math, biology, elective maths, and chemistry. So I started there. Then I was there, but before I got to PSEC, that's an interesting story. So I got my results. I went to PSEC to see the chaplain, and he asked me, "What do you want to be in future?" And I said I wanted to be a computer scientist. And interesting, he said no. He said, the chaplain of PSEC said, no, I should think much deeper. I should think about how I can apply the computer science and not just say I want to be a computer scientist. It was weird to me, but I took it in that under advisement. I said, okay, I would do that. And I started during my time in high school at PSEC. I started thinking about what could I do, and I was thinking more of the Ghanaian aspect, things that I can do which are related to using the computer. So at the time, I was thinking of civil engineering because of computer-aided design and other things that you could do using the computer in the civil aspect and still do a lot since Ghana was a developing country and had a lot of that. So by second year of PSEC, I decided I would do computer science. To do civil engineering instead of computer science. And I went to the Kwame University of Science and Technology. And and then subsequently, after my time, I worked as a highway and traffic consultant in highway. And there was time that I decided to, after my national service and my time as a consultant, to go back to school. And this time I decided to enroll in a couple of universities, New York University, University of Delaware, and then I got a full scholarship to go to the University of Delaware. And that's where they sparked my interest in data science. So basically what happened was I met my advisor, Professor Nii Martey Jr, who was heavily involved in data science at the time. And he asked me, did I want to work or do research in railroad engineering or highway pavement engineering? I said, I'm railway engineering, because I was somebody who liked to learn a lot. And then an interesting thing about railway engineering is that we had a lot of analysis in that aspect. So it brought me into contact with so many people, so many tools that I used to do analysis in railroad engineering. So from railroad maintenance, degradation and recovery models to railroad and accident, derailment, severity analysis. There are various aspects. And now we're doing some of these projects and some of these research projects for the Federal Railroad Administration, some of them for various Class 1 railroads in the United States. And that's where I began to pique my interest, because I had to take some of my advisor's courses like advanced data analysis, which we did a lot of heavy machine learning, probability and statistics. So that's where it began to pique my interest, and I started to look more into it because I had to learn. That's why in 2014 I had to learn R and Python. That's where I got in love with the two languages. And as time went on, I had to learn other stuff like SQL. So a lot of it was some classes, some of them were self-taught. And when I was done with my master's and PhD, I decided to move to the Federal Railroad Administration in Washington, D.C. The Federal Railroad Administration is under the Department of Transportation for the federal government. And what happened was I, again, had the opportunity to continue using some of the tools that I picked up, use R, Python, Tableau, AWS, SQL, SQL for relational database, and so many things. So that was an interesting time. Then it was a contract. So after I was done with the Federal Railroad Administration as an ORISE Data Science Fellow, where I did a lot of data science projects for them, I moved to Insight Data Science. And Insight Data Science, I was part of the 20B Insight Los Angeles cohort. And over there, I did what Insight Data Science did for me was it helped me to be a much better data scientist. But my time there had twofold. There was one in which you had to do a project. So I did a consulting project, which I'll get into later on. And there was a second bit where they helped train us to be like better data scientists. And then after that, through Insight, I came to contact with recruiters from Capital One who asked some of the fellows whether they're interested in working with Capital One. And then I went through the process of joining Capital One by going to about 4 or 5 separate interviews. And then along with applying to other places, having demos and interviews with people like Disney, Kemper, and whatnot. And then I went through all the interview, which I'll talk about the various type of interviews that typically you will find in data science. And then I got to the role at Capital One, which I also go into later on.
All right. So you've given us like a peek of your background, which is from Presec to KNUST, study civil engineering, then being a TA, and did some consulting in Ghana, went to further your master's in University of Delaware, where your You said your supervisor actually your PhD advisor actually introduced you into data science.
Yeah.
And then that became the new path you've chosen. Early, the path that you've taken is similar to the others that I've interviewed, showing clearly that it's not about where you started from. Once you get an interest and a passion for data science, you can always find or chart a career in data science. So, I mean, anybody listening, you can know clearly that it doesn't matter where you started from. If you have the passion and the interest, you can also become a data scientist. Having told us that, the next question I would ask is that what has been your the greatest challenge as a data scientist, as working as a data scientist, after university or now in practice? What has been your greatest challenge as a data scientist?
So the most challenging work I've probably encountered so far, I would say, is during my time at Inside Data Science. Like I said, Inside Data Science was a very interesting time in the sense that as part of our time at Inside Data Science, all fellows who were selected had to come up with various projects. And one of the projects that I chose to work on was a consulting project. And this consulting project was for a professional drone services company. And the issue that they had was they worked for a client who were in the environmental industry, wind turbines, to be more specific. So the issue they had with their wind turbines was that the drone services company comes in. I can't mention the drone services company's name because I had to sign a non-disclosure agreement when I was working with them. It comes with the territory and sometimes working with data science, in data science. So what happened was I had to, in 2 or 3 weeks, come up with a computer vision model which could detect various damage in wind turbines. Sorry, could you hear me?
Can you take the assignment again? I think there was some network issues.
Okay.
If you could take the network part. Hello?
Yeah, I can hear you. Okay. So where do you want me to start again? Hello?
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 Hello? Yeah, can you hear me now?
Yeah, I can hear you now. Perfectly clear.
Okay. Yeah. I think you'd have to take the work at Insights again. The client, you said the client being a an environmental issue with a wind turbine. So you need to take that again because we could not hear you.
Okay, so like I was saying before, the most challenging work that I had so far in data science was during my time at Inside Data Science. Like I said earlier, all fellows were supposed to come up with projects. It could either be a personal project that you come up with, which you start with conceptualization to deploying your model, which is very important for any data scientist. And the second group of people, that is, you do a consulting project. A company comes with an issue that they have that you're supposed to solve. And one of the projects that I ended up getting was that of a renewable energy, a professional drone services company who had a client who had the renewable energy industry. And they had a lot of wind turbines. And the issue they had with wind turbines, the professional drone service company comes in, takes pictures, and analyzes the various drone images. And then what they do is based on whether there's a damage or not, they will ask their engineers to fix that. But it took them a lot of time, a lot of analysis, because they were manually doing it. Like they'll go through the image, look at it, and say, okay, this has a damage or has an anomaly in it. And then they'll categorize what type of anomaly it is, and then tell their engineers what to do. So what happened was, within 3 weeks, I was supposed to come up with a computer vision model which would detect and capture or categorize these type of anomalies, the various types of anomalies. And 2 or 3 weeks is a very short time and could be very challenging. And when the data initially came, I had the issue where, I was given some of the images, which typically they will label. So it becomes like a supervised machine learning. So when we say supervised machine learning problem, supervised in the sense that you are guided by a certain response variable. So you know, in this case, our response variable could be whether there's a damage in the image or not, an anomaly in the image or not, or you'll be able to detect what type of anomaly is or damage is in that image. So when it came, I realized that there was some misclassification of the data, and that led to the need for me to do data cleaning. And these were about 5,000
images.
About 13,000 actually, 13,000 images thereabout, where you had some misclassification. So I had to go through. Initially, when I was doing the training, I realized that, like you see, garbage in, garbage out. When you have your data, the input of your data, you have issues with it, the results will be so good. Yes, can you hear me? Yeah, so your data might not, the results might not be so good. So I sat down, I told them about it, but when we did the query again, I was still having issues. So I went through the data, did cleaning of the data, like reclassification of the data. With that, within the whole weekend, I just sat down, did that, and then I built my convolutional neural network model, which I used to classify whether there was an anomaly in the data or not. So what happened was, I ended up building using AWS and Flask to deploy my model. And then what happens is, it tells you immediately, once you input the data into your computer vision model, whether there's an anomaly or damage in the image or not. So to tell you, and easily you can flag it. So that was the first step that we were more interested in. Then we had a second model which did more of categorizing what type of image damage was in the image. So all that was done in about two to 3 weeks, which was very, very challenging, because I had to do cleaning, and there was a hard cut that once after week 4 of Insight, nobody's supposed to work on any consulting project or personal project. So you need to get it done, and then we'll move to the second stage, which was more about trying to help you when it comes to interview preparation for if you want to work with any company and data science company. They are setting.
So Insights was more of a fellowship.
Yes, so Insight was more of a fellowship. Okay. So after I left the Federal Railroad Administration, that is when COVID hit. I was in some interviews, and I saw that Insight had come. I have 2 or 3 friends who had gone to Insight. So Insight's data science. So I applied to it whilst I also applied to other places whilst I still work at FRA, and I got it. So that was quite a good time, and I decided to go to Insight. Some people were like, "Oh, you're already a data scientist. You've worked at Federal Railroad Administration. You probably don't need it." But when I went there, it opened my mind to so many things, how to be a better data scientist, working with, like I said, I worked with some consultants. So it gave me another view apart from the Federal Railroad, how others in industry work, and the various, I had to have meetings with them every day for them to know what I was doing, and all those.
Yeah. There are so many points or so many things you've said that I would take time to query so as my listeners would be able to understand. A chunk of them may just be first level data science people who are just head of data science. So for their sake, I will break down some of the things that you've said.
Sure.
One key thing here is that after the FRA job, you decided to enroll in a fellowship where you'll be taught like how to actually become a better data scientist in the industry, as well as get projects to aim that you are in. Right. So it comes to that one key thing here, that to be a good data scientist, in one way or the other, you might need some form of mentorship, right?
Yes. Yes. You get some form of mentorship. So becoming a better data scientist, there are, for example, like I said, like the second aspect, the first aspect. So apart from me meeting the clients all the time, there are people on Insight who are also looking at quizzing me. Why did you use this method? Why do you do this? Why do you do that? And then sometimes some of them will give you constructive criticism on the project that you did, the same way they did for like every single person there for the first 3 to 4 weeks of the program. And then there was the second aspect, which where it was interview preparation. So they just showed you some things that I'd gone through some data science interviews, but I didn't take notice of, or I'd never encountered, because depending on the company that you work for, you meet various types of interviews. So we would
in your last part, I will talk a lot on how to ace a data science interview, because you are very much trained in that with the help of your Insight Fellowship. But let me now go a little exploratory on the project that you did on the computer vision. First, help us, especially driving for the first time. Some may just think that it's just visual or vision on the computer. Can you take us through just briefly what computer vision is? I mean, using computer vision to solve problems.
So basically, when I say computer, we are talking about a computer vision model, where we are. So, for example, let's look at it from human vision. The human is able to picture and interpret what
you see
input that you get, what you see. So you see, you the human, your human vision and your mind, you take in the image. So I see that, oh, this is a boy or this is a girl, based on some you being
training that you've had,
that your parents or your teachers told you that this is a boy or this is a girl. The same way with computer vision, it's similar, in which the we model it similar to the way the human would envisage something and try to interpret it. So what happens is you feed your model with data. So for example, in my case, I had to feed the model with images, wind turbine images. So the wind turbine image, so it tells you give it a whole bunch of, let's say 15,000 or 20,000 images, which is a bit small. You should even have a bit more. So let's say 20,000 images. And among the 20,000 images, we are telling the model is saying that this is a cat, this is a dog. In my case, this has a wind turbine damage. This has no damage. This has damage. That has no damage. So you keep training the model. So you use, in our case, we use convolutional neural networks. In my case, what I used was a residual network. Residual networks are longer, much deeper neural networks. And I can go into why we use residual networks, but I don't want to bore people with.
I mean, maybe I'll intentionally do a special session with you on especially advanced machine learning algorithms and computer vision, deep learning stuff. But for now, you've actually explained it brilliantly. Most of the time, it's the same thing that machine learning is about. You train the machine to be able to recognize something in a certain way. So as next time, when you show him the same thing or something close to it, we'll be able to dictate and tell you that it is this or that. So
yeah, so what I did was to train. What I did was to train this model with all this bunch of data. So what you do is you have to split your data. You split your data into training set, a validation set, and a test set. And usually you would validate the performance of your model and test it on your test set. So what happened was I had quite good, about 97.3% recall. That was about 98.5% test accuracy. So the model did quite well, if I should say. And hello, are you there?
The training sets and the recalls that you got.
Yes. So like I said, so I had about, my test set was about 15% of the data of the images. I can go into, like I said earlier, the data pre-processing, which I can talk about, but it will take a while to just go through the various methods and techniques that I did. And then the next thing was to look at that model that I had. And I'd done an earlier model, just compare the two models. The first model I did, which was a plain neural network, and comparing with the residual network, you realize the residual network did very, very well. Like I said, it had about 98.5% test accuracy. So it was almost accurately predicting whether we found a damage in the turbines, in the wind turbines or not. And subsequently, we had more time and we went into like further analysis, which I will not bore you. We can talk about it when we get to the deep learning.
A damage.
She said something about the damage. Hello?
Oh, no.
Can you hear me? Hello? Ebenezer?
Can you hear me? Hello, can you hear me? Hello, can you hear me? Hello?
Hello?
Hello, can you hear me?
Yes, I can.
So, sorry for the network, viewers. Dr. Emmanuel Martey was taking us through his computer vision model. As I said earlier, computer vision and how he explained it is just like everything about machine learning and all the things we are doing with computers are mimicking how human beings do things. So he's saying the most challenging assignment was given 3 weeks to train the computer to be able to identify whether a certain picture by a drone company that was taken of a wind turbine was faulty or had a damage or not. Before he actually did that work, they had to manually go through all the pictures to determine whether there was an error or there was a damage or not before operation guys can go in and do it. So with his model or whichever system or algorithm that he used, you are now able to predict, okay, this is faulty, this is not faulty. I'm sure computer visions are used by Facebook and the likes to identify human beings and pictures that we post. And sometimes they are labeled and not labeled. And that's why he went into supervised and unsupervised learning. As you go into more on data science and machine learning, you'll be able to appreciate unsupervised and supervised learning, where you have a data set or a certain image which is already labeled by the end user. So you have something to guide you. So it's like you teaching your kid that, okay, you have an image and the image has a name on it. This is a dog, this is a cat. So it's already labeled. And that is what you use to train the child. But in some cases, you can have data sets that are not labeled. Like, so you're a teacher, but you don't have the label of the image in there. And that's also another form of analysis. But he did a labeled method and classified it and was able to now help the company to be able to. This is some real hard work. Like, it takes a lot of work, I guess.
Yeah, it takes. So first of all, I'll say yes and no. So yes, there are already various packages that if you already know Python and you know how to use TensorFlow and stuff like PyTorch, you are able to do do deep learning like fairly easily and quickly. The issue comes where sometimes you need to interpret what you've done, or where you need to, in some cases, explain to people what is happening behind the hood. Because for a lot of people, they see machine learning or deep learning tools as a black box. So now you have to explain to them why, or use various things like Lime, various things which will be able to interpret and show your clients what exactly is happening under the hood, how your model is being able to classify the various, which are the various type of layers, your neural network layers, what each of them are doing. Some of your clients might be interested in that because sometimes they get a bit skeptical. They become skeptical. Some of them are just enthusiastic and they want to know how is your deep learning model, how is your convolutional neural network model able to detect whether it's a cat or it's a dog or it's a aeroplane thing or all those things. So that is something we can talk about later on.
I think what you said comes to my next question. I was going to rob into which tools you've been using. You've mentioned a lot of the tools that you've already used, and this is high level data science. So what I wanted to, like from what you just said, clearly you could know the tools, but most important, what is required of a data science to understand the concepts?
Yes, you need to, in most cases, understand the concepts and be able to explain in layman's terms what is happening. So it requires you knowing the assumptions that go into the model, when the disadvantages and advantages of using certain types of models, and when to use supervised learning, when to use unsupervised learning, when is the best time to use a simple traditional machine learning algorithm, and when you should probably use a deep learning method, which comes into play especially when you are in industry, because industry are more interested in getting quick, efficient results as compared to academia that are looking at state of the art and we are trying to get the best model, and we don't care much about how quickly you get things done and how your model runs.
All right. So it comes back to, so clearly, like you are alluding to the fact that learning the tools is quite easy. The challenge mainly is explaining what techniques or what is behind the results that you are getting.
I'll say yes and no. I wouldn't want to say that. It depends on everybody. Like some people are very good at math and statistics and like other things like coding, programming. It's very simple and very easy for some people to use. The others who are very good, they can explain to you. What random forest does or logistic regression model that's a neural network model. But when it comes to, so it depends on the type of individual. So I'll say it depends on who is. So for some people, it might be easier for them to explain some of this. For others, it might be easier for them to talk about. Yeah, so it depends on the individual.
Okay. My next question is the tools. So quickly run us through some of the tools you've used.
Yeah, so there are various tools that I've used, like Python and R for a lot of the coding, depending on where you work. Like at the Federal Railroad Administration, I used more of R. Also during my PhD, for some of the projects that I did, it was more statistical, like coupler models and Vine coupler models. I'll use like R. But if it was a project in which I was using, let's say, random forest or logistic regression or support vector machines, I would end up using Python for that model. So it's different. At Capital One, I use mostly Python. I had to use R. And then back in school, I also used MATLAB, but MATLAB is proprietary, and proprietary programs are not used as much, like MATLAB are not as much in data science. Most of them are free source, like R and Python. So that's like some of the programming language. Then you have the data visualization tools or business intelligence tools like Tableau, Power BI. For most of the places that I worked, a lot of them use Tableau. So I've used Tableau for that. Then there's the relational database for you to do queries on your data. So in that case, we used SQL, Structured Query Language, or SQL. There are various variations of Progress SQL, Microsoft SQL, there's Oracle's. There are various versions. So, but the bottom line is you being able to understand and use SQL to run queries. But more often than not, you don't have a database administrator who will come in to
do that for you.
The data query for you. You should be able to go into your company's database, run a query, get the data, ingest the data into whatever environment you use. If you are using, in our case, at Capital One, we have something called Legoland, which I won't go so much into. They have like others use Anaconda or Jupyter Lab. People use Google Colabs to do their Python and all those things. So to get into the environment, run the analysis, and once you're done with your analysis, then you start thinking about how will you deploy your model. So in deploying our models, we have various tools that you can think of. Some use Heroku, Flask. So some of them in Python, you use Flask, and the Flask Python package, and then you deploy it on Heroku or you deploy it in AWS, whichever. Some use Azure, whichever place you're using. If it's
who is best for deployment?
So I'll say best for deployment. The problem with Heroku is Heroku has a limit on how much. So if you are using deep learning models and it gets really big, you might have problems when you want to deploy in Heroku. So the best will be to deploy in AWS.
AWS, or yes. That's Amazon or Microsoft, depending on.
So AWS is Amazon Web Services, and then Azure is for Microsoft. So I've done most of the places I worked with. Federal Railroad, Capital One uses AWS, Amazon Web Services, And then the work I did at Insight with the professional drone service company too, we used AWS.
All right. So now let's come down to, now you're doing some, hello, can you hear me?
Yes, I can hear you perfectly well.
Okay, now let's come down to, how does somebody begin? Like you've said, now you're into deep learning stuff with lots of models. You are like an advanced data scientist now, like in the real world. You've done it also in academia. How can one start? Let's say I'm a beginner, I've just completed uni. How can I start so as I get to where Dr. Emmanuel Martey is today? Where do I begin from? How can one start his data science journey?
So data science, I'll say, is a combination or union of three different things. The first part is math, probability, and statistics. There's a second bit which has to do with the computer science and algorithms and programming. And the third bit is your domain knowledge or domain expertise. So the domain expertise is something I'll put on the back burner for now. Let's talk about the math. You should have a good math and statistics background, probability, be able to know, for example, what hypothesis testing is, know what a p-value is, and how you interpret various models, the various statistics that we've learned in school. All those things come into play when you're using in data science. Then there's the computer science aspect that you'd also have to be cognizant of. That is things like data structures and algorithms, which is very important because it helps you to be efficient data scientist. What's a dictionary? What's a list? What's a tuple? What's an array? And all these things, how you use them, when you should use a list comprehension, when you should use dictionary comprehension. All those things are some of the things that you will learn, that you can learn either in class or on your own. So with me, what happened was I took a lot of classes. Apart from some of the classes I took in school, I went online. I used YouTube to learn some of these statistics, learn some of the computer vision, computer algorithms, machine learning.
The network.
Sorry, could you hear me?
You said you did some classes and went on YouTube also.
Yes, and I also went on YouTube. I used Coursera. I use Data Camp. So we have Data Camp. We have Coursera. We also have a few others, EDX. Like I used various ones, like when I started out, because there are some you get on YouTube. Some people teach you how to use Java, teach you how to use C code, teach you how to use R, teach you how to use Python, like various aspects. But when you go to some of these Data Camp, Coursera, some of them, they take it step by step, similar to YouTube, but then this, you also have the opportunity to do some exercises and not just take it in, but then you are able to do some of the exercises on their various platforms like Coursera and Data Camp and EDX as well. So those were like, what I'll say for most people is, if you can, and you're very interested in data science, in the last 3 or 4 years, most of the universities in the United States have started offering data science masters. So that will help you be competitive. The next thing you have to do is you have to be very self-driven. So you need to teach yourself so many of these things that I mentioned. So using for visualization, Tableau or Power BI, or in the case of R, there's a package we call ggplot2, which is good for data visualization. For Python, we have the traditional, we have Matplotlib, we have Seaborn, we also have Plot9. Plot9 is similar to ggplot. So Plot9 is ggplot. R is to ggplot as Python is
Plot9 is to Python.
So a lot of people who moved from R to Python were very interested in Python. They were very interested in R, but they realized that Python didn't have a package which they had much of the functionality that
specialization.
So what someone did was to just come up with the same functionality, a package called +9, which has the same functionalities as your what your ggplot2 will do in R, and that's what some people use. So you realize that most people will use matplotlib, some of them Seaborn, but then all of a sudden a lot more people are using the +9 package. So
all right. So I think you've made it very clear that if you can afford, a lot of universities in the United States currently are doing masters in data science. If not, you can also take advantage of the internet and enroll in Coursera or EDX courses or any of the other training institutions that are online, as well as YouTube is like the mother university today. But at least for the Coursera and the EDS and the data camp that you talked about, that one, at least the person will be able to get step by step what to do. And then maybe we can get further videos on YouTube to help to understand. However, there's a full master's program out there. I'm praying, like the last time I spoke to the last interview, I think Sarah talked about the same thing, that Ghana has not started any specifics in data science. It's just management information system and the likes. Yeah, so hopefully maybe some of these engagements would open up the space where people would now be teaching, like would take data science as a master's course in Ghana, and people can actually enroll. But I mean, that's a brilliant exposure that, people can actually, you can see that all three of my interviews so far are saying similar things in terms of how to get into data science, how to start. One thing that you've highlighted is a self-will, because most of the things cannot be taught in class in a certain way. You have to want to go out there and get and find it. And that is one of the key things I've seen, that to be a good data scientist, you have to have that self-will and the love for probably data and an interest for data to be able to succeed. All right. Now let's dive into, okay, so now the person has now gotten an interest and started some courses. What are the opportunities out there, especially you being in the United States? We've talked about the Ghana side with Sarah and Dr. Asante. Dr. Martey, what are the opportunities? So as somebody may want to convince himself that, Charlie, this is the place I want to be. What are the opportunities in data science?
The opportunities in data science in the United States and in most of the Western world is really huge. It's one of, like Sarah said, a lot of people say it's the sexiest job of the 21st century. It's one of the most growing. A lot of people need. So almost every industry has data and needs of data, and most of them need to, out of the data, like my PhD advisor would say, you have to beat the data till the data tells you the truth. So most of them want to know what is.
Say that again.
Yeah, so my PhD advisor can always told us that beat the data till the data tells you the truth. So
you have to beat the data
till the data tells you the truth. So you have to quickly examine all your data till the data tells you what the true story is. So if there's a need for you to do cleaning to get the noise out of you try as much as possible to beat your data till your data tells you the truth.
Okay. So there's enormous opportunity out there.
Yeah. So from the financial industry to health industry, there are a lot of data scientists in the health industry, a lot of in pharmaceutics, a lot of data scientists in the financial industry, in the tech industry, Amazon, Facebook. Think of any Fortune 100 or Fortune 500 company in the United States. They would use a data scientist, or they are in need of a data scientist. Majority of them do. Even when you come to the engineering field, you see that we also collect data, and there's a need for people to. So you see a lot of the big civil consulting companies in the United States now. Some of them on various different projects, you might find that they'll have a data scientist on that project for one reason or the other, that they are making use of. The data scientists know how to drive data-driven solutions for their business. So almost every industry has the needs a data scientist. Yeah.
So you mean that there's an enormous opportunity. Once, from what the takeout is, once there's data in an industry or in a business, it requires that they have data needs, and which would, if they don't even employ now, they would need somebody to actually beat the data for them and tell them what the data is. So
yeah.
All right. So there's enormous opportunity. So viewers,
everywhere.
Yeah. That's exactly what I'm trying to do to help people to know that there's enormous opportunity. Because just think about it. Now we are collecting data on everything we do, what we eat, what we wear, where we go, everything is being captured. Definitely, at the end of the caption, somebody would have to sit down, beat it, make meaning of it to the decision maker. And there lies the opportunities that data science brings. So I'm hoping that a lot more people would get into data science with these opportunities. You are somebody who works with a Fortune 100 company. You're from Ghana, you're from Presec, you're from KNUST, and then went out and now have aced a job with a Fortune 100 company. Can you now take us through how, like if somebody's watching as a data scientist, how they can ace a data science job, or some of the skills they would need to ensure that they can, even after their education and their tutoring, they can ace jobs in data science?
Okay, so let's start by the preparation that you have to do before that, showing proof of concept of things that you did. First of all, like we say, your resume would get you to the door, but to go into the door and reach the finish line is where the interview comes in. The first thing is your resume. So some of the things you can do to make your resume look good enough. Obviously, the best thing is experience on the job, internships, but it's not always that you have it in that case. So what do you do? It's sometimes I tell some people that it's always good to be able to do some individual projects, put it on GitHub, and in your resume, show that link.
Reference it.
Sorry?
In the interview, just reference it.
So not in the interview, because now what you are trying to do now is to get your foot in the door. For them, okay. For the HR or the hiring manager, when the person sees your resume, oh, you're very good, because they get a lot of resumes which come, and they look at it for like 1 or 2 minutes and they let it go. Though there are things that you need to highlight, and so it starts with how good your resume looks. So in that case, be able to highlight the various techniques that you've used, the various tools and frameworks that you use, the various experience, the various projects that you've done in data science, whether on the job or individually, you put it there. And when you are listing out on your resume, there's a way we call them, it's the SAR or the SAR format, which we can go into later on, where you'd be looking at the actions and the results and all that, and try to formulate your resume in that manner. So that's one way to go about it. And now there's the interview preparation. Okay, let's say you had a good resume. Perfect. You are going to be called to an interview. What is there? The first part, and for most people, is you get a call from the recruiter. And when the recruiter calls you, or the hiring manager, it might be very, very formal. but it's an interview. It's a behavioral interview in which they are trying to get to know you, who you are, what makes you tick, whether you'll be a good fit in their company, whether you are really interested in their company or not. Because some people just apply to the company. And anytime you're going to have such an interview, you should start by researching into the company. If it's Capital One, okay, so you start researching, what do Capital One do? What are the various ways in which they use data science? If it's Disney, what are Disney streaming services? Or it's Amazon, or it's Uber, or it's Airbnb? How do they use it? In those cases, so that you can relate during your interview with the recruiter. So a behavioral question, they'll ask you, tell me about yourself. And more often than not, most people would start saying, dumping their resume. But in that case, it's an opportunity for you to tell them what makes you tick, what makes you interested, why you went into data science, what makes you interested in data science, what makes you a cut above everyone. Through that, tell me about yourself, you're able to tell them. So it doesn't become just a dump of, oh, I went to school here, I want this, I did that. So the behavioral, they'll be asking a lot of questions. They might ask you that, tell me about a time in which you showed initiative. Tell me about a time in which you showed teamwork. Tell me about a time you had conflict. Tell me about a time. So even myself, sometimes I struggle with those things. Those are sometimes some of the most difficult ones that you might encounter in a behavioral question interview. They just want to know your behavior. So that's one type of interview. So that's the first type of interview. For example, when for most companies that I apply to, you might end up getting and they just want to know. They'll ask you other questions like why you want to join them, 3 reasons why you want to join them. Other questions which might be related to whether you have visa, you have authorization to work in the US. Sometimes you might get some of those questions, and then they will know how to handle it. If you're a citizen or a permanent resident, fine. Then if you are an immigrant, then they will know how they will handle in your case. If they are going to go forward with you to the next round, they will know how to handle it in terms of all the immigration things that they need to work out before you be onboarded onto their company. So that is a behavioral question that sometimes some people don't get, and they're not able to show that enthusiasm and show that they can work with, they have this
others.
Yes. So that's one. Then we have the technical aspect. The technical aspect, there are various types of interviews that you have. One, which is another one, which throws people off, is what we call the case study. So the case study, a data science or a business case study, in which they throw at you an open-ended question or a scenario, and they'll ask you, as a data scientist, how you're going to do it. An example of a technical a case study question is, for example, they can start with a very open-ended question. You are a data scientist at Twitter or let's say Facebook or any other social media company, and your bosses or a product manager comes to you and says that you have an idea of a new product. Let's say video calling. We want to start video calling on Twitter. And they'll ask you, how would you go about it? So sometimes you don't even get the question, how you go about it. So they'll ask you. So in this case, we want to bring video calling onto Twitter. Would you launch, we have this product, would you launch the product or not? So when they ask you, will you launch the product or not? Somebody will say yes or say no. There you are losing, straight away you are losing it. So now what we want to do is for you to ask a question, because case study questions are supposed to be conversation, not interrogative. So now what you do is you begin to ask your interviewer what type of, like, more about the data, more about the decision. And then you start talking about this thing, why in any case study, you start thinking about what is the key performance indicator. Every business has a key performance indicator, something that they're interested in. For example, for us in the financial industry, and for most industries, it's profit.
Yeah.
Most of us are interested in the baseline is profit. There are others who also have things related to customer service, other indicators. Some of them are interested in user engagement, and for them, user engagement will invariably lead to profit. So in the case of Twitter or Facebook, they're interested in various products which will increase user engagement. And then the user engagement with the various forms of marketing that they have with click rate and those things, they believe that it would improve on their. So you start asking them questions, and you have to start thinking like a business person. You can't be thinking like just as a data scientist, but you also have to think about what does a business want and how you will go about it. So you start asking your interviewer questions, and you answer. He'll give you questions about Twitter and all that, and then you can start answering the question like, how will you go about it? In this case, Sarah talked about A/B testing, which is like random control test. So what you are going to do now is you're going to tell your product manager that, okay, so the whole idea of bringing this is we are thinking about user engagement, increasing user engagement. So we are going to run a randomized control test or an A/B testing. It has to be random, so there will be no bias, and you have to check for that randomness. And what you are going to do is we are going to put Twitter users into two groups. Maybe in the first group, you have people who are
with the video call
exposed to the product. You expose. So sometimes you realize that you be on social media and some of your friends have a certain feature now and you don't have. Sometimes it could be because you've not updated your app, but in other cases, it's because they've chosen a few people for a test. So what you are going to do is you are going to have what you call hypothesis testing. You are going to test the hypothesis. And what's the hypothesis? The null hypothesis is that there will be no change in when we introduce the video calling on Twitter, there will be no change in user engagement. And the alternative hypothesis is if we introduce the calling, there will be a change in user engagement. So now you have your null and your alternative hypothesis. Then the next thing you have to do is, like any statistician, you start choosing the type of test you are going to do. Is it a z-test, a t-test, a chi-square test? Why are you using a z-test or a t-test or a chi-square test? You must know when you use it. They'll ask you those questions. Like when you see you're using it, why are you using it? Then you start talking about significance, p-value. They'll ask you what is p-value, what's probability value. So as a data scientist, they want to be able to explain yourself from conceptualization, how you do it, and then how you deploy it, how you evaluate your models. So this can end up taking about a whole hour. So when I was doing my interview with Capital One, it took the case study question, which was the second one, took me about an hour, in which we're just talking about, and they didn't give me something on Capital One, they gave me something on Comcast.
Okay.
I assumed I was a data scientist at Comcast, and then you were throwing questions and we're talking to. And the funny thing is, the person who interviewed me later is one of my team members, also a principal data scientist on my team. And that was like really interesting. When I told him, he had forgotten about it because he interviewed so many people and he was on the phone. He didn't even know that he had met me already. And that was an interesting thing. So it shows that it's very competitive. So that is case study. I can go into it, but I won't talk so much about it. Then there's another aspect which has to do with machine learning algorithms, concepts that people will ask you. They'll ask you what, for example, what are the hyperparameters that you use in logistic regression modeling or in modeling? Because most of the time people use they use it as a black box. they just take the default settings that they see in scikit-learn on Python and then come up and just run an analysis. But the best thing is to,
I think,
sorry.
What I'll do is that I'll intentionally have a special session on you on the how to ace a data science interview. Because you can go deeper into each one of these things that you've said, right? From the how to prepare your resume, the SAR format, the going through making sure that you have links that you can show the hiring manager that this is proof of what I've done, because that is what would distinguish you from maybe a lot of other resumes that are coming. That's why it's important that you publish works and deploy works maybe into GitHub and other places where they can easily be seen.
Academia too, it's also proof of concept. If you have, for example, a machine learning paper in a certain conference paper or a certain journal, it's out there for everybody to see. And when I was my boss told me in the end that he went to look at some of my papers. He had seen some of my papers that are done both in statistics and machine learning in various places. So hiring managers and directors actually look at all these things. They go looking into your GitHub. They go into looking at papers, at some of the work that you've done, some of the places you've been. Yeah, to just sometimes it's just verify.
Wow.
And all those things. Yeah, so it's quite important.
All right. I think you've taken us through a lot, and I hope my anybody with any question or comment should actually put it down there. So I'll definitely interview Dr. Martey a second time, especially based on the questions that you asked. The last two questions I'll ask is, I mean, now everybody is talking about how sexy data science is. What is the catch? What is the pay?
The pay.
Yeah,
that's it. So most of them are 6-figure. I would say most of them are 6-figure. You can, depending on wherever you are. If you're in San Francisco, you can be getting average maybe 160,000, depending on where you are. If depending on the level, for entry level, for most places in the United States, you'll be looking at entry level. That is maybe a data scientist, like a junior data scientist, over $100,000. A lot of
year.
To get a year. In some places, they might give them 90, but a lot of places they would end up giving them over 100. So
all the way to principal. Can you give us range?
A range for which one? So also
to principal.
So for a principal data scientist. So the principal data scientist, well, it depends on they look at so many things. It also depends on the company you are in. So some companies you could get as much as 150,000, some 140, some 160. So it depends on which company. 50,000. That's a year. So
so that's lucrative.
So yes, it's a very lucrative.
Yeah, it's very lucrative. No wonder they say it's sexy.
You're like, you tend to agree. But there are also some companies who would take a data scientist but will not pay you as much as the 140s, 130s. Some of them might want to pay you, like I said, 90,000. But on the average, when you compare it to other jobs, it's still very high.
Right.
It's still high. So you would see people, I know people getting over 200,000 as data scientists, or I know of people getting more than 200,000 as data scientists. So it's a very lucrative job, and that's
to go into
because of the money. Some have the love, some of them both. So it differs on whoever it is.
Or where you are going into, or why you are going into.
Or why you are going into, yes, exactly.
Right. So your last and final words to people listening to you, especially people with ambitions to be data scientists, people with wanting to have careers, the young people of Ghana. We are already in an election. Almost some, So what would you say that the young people, what is your final words?
So I'll say that as anyone who wants to be a data scientist, you should think about it from the role of a business. What would your business or your boss want you to do as a data scientist? As a data scientist, you should be able to start from conceptualization, be able to think of the concept. Once you're given the concept, think about it, up to deployment, where you'll be able to deploy your model for others to use. So in that case, you also have to develop various aspects of being a developer. So you must have some traits of a statistician, traits of a mathematician, traits of a computer scientist, traits of a domain expert. In some cases, in some companies, need traits of a data engineer, because which I can go into at another time, why data engineering might be important for some roles and what's not. So all I'll say is, whilst you are trying to be a data scientist, make sure that you're able to put your work out there. Your work is on GitHub. Your work is on, if you're in academia, be able to publish your work in conferences or journals, which is out there for anybody to see. If somebody Googles your name right now, you're able to see some of the works that you've done. If you've been able to, on your resume, you're able to show various and well-documented what you've done, in which situation did you do it, what's the action was done, what is the result. Because it's, if you just write that I did logistic regression, what did you use logistic regression for? What was your company? Why were you using logistic regression? What was the results that you had? And how did, for example, your model improve the baseline? So you could talk about how the model improved on what your company was doing before. So at first, your company was probably using, let's say, logistic regression, and then now you're using random forest. How much did it improve in terms of your metric? Did it improve by the baseline? And that will make you, I believe, will make you a better data scientist. So, so I have for your listeners today. There's a lot on my mind. There's a lot.
Like I said, I would have a special second time with you. Maybe after I've done some preliminary interviews. There is a lot I've learned myself. Viewers, I'll try and put in the link and the bio some of the terminologies he's used and links to them that you can learn on your own. Has been very, very educative. He's like a practicing data professional, data scientist, and he's in a very advanced form. You can see clearly from our interaction that there's a lot for him to share. So I'll get to you, Dr. Martey, on a special time and probably talk more on deep learning, some computer vision stuff, and some machine learning algorithm. For now, I think we've learned a lot from you, right from the beginning on what you've done, the challenges, the how to ace an interview, what to do, what to look out for as a data, especially the concept-based approach than the tool-based approach, that understanding that you need to learn how to actually, even your thinking, the way of thinking as a data scientist, because that is what will be tested during your interview, not just the works that you've done. So, I mean, you talked about conceptualization till deployment and also understanding the bottom line for the company. That is the metrics where the company seeks to improve. You said one nice quote by your professors, a data scientist, you have to be the data till it tells you the truth, right?
Yes, it tells you.
So thank you very much, Dr. Martey. We'll catch you some other time. Viewers, I hope you've learned a lot. Ask any questions you have in the comment section, and I'll get in touch with Dr. Martey later. Thank you very much for your time.
Thank you very much.
So much
for having me.
of an eye opener. And my regards to everything, to Capital One and your group. And thank you for your time once more.
Thank you very much for having me.
Viewers, I will catch you later. Bye.